Okay, who will pray for us today? Daniel Ayo, please pray for us.
In Jesus' name.
Amen.
Amen.
Father Lord, as we are going to be starting this class, Father, grant us understanding in the name of Jesus.
Amen.
You must grant us understanding and intensive memory, and let this class be active and not be boring in Jesus' name.
Amen.
Amen.
In Jesus' mighty name we have prayed. Let everybody say amen. All right. We are starting right away. Last week we started a new topic, carbon and its compound. And we were able to look at the allotropies of carbon. And we concentrated more on one of the allotropies of carbon, which is diamond. And today we'll be looking at the second allotropy of carbon, which is graphite. Okay? And before we continue, I gave you an assignment last week. Just very few of you did it. I want to encourage you to always do your assignment.
Sir, this is my assignment.
Sir, this is my gift. You will see. Actually, we were asking not to know.
Okay, I gave you assignment last week. Oh, you didn't get it?
Sir, we got it. Sir, this is my assignment.
Sir, this is our assignment.
Yes, those of you that have sent, it has been
It's
marked
okay.
and returned back to you. But I know some of you didn't do it. So please, I encourage you to do your assignment. That is the way to learn. By the time you do your assignment and you get back your correction, you will know where you made mistakes and then correct yourself. Is that okay? So we are continuing with the subtopic graphite. Graphite is one of the allotropies of carbon. And these are the contents we'll be looking at today. We are going to look at the properties of graphite. We look at the structure of graphite. We look at the differences between diamond and graphite. We also look at the uses of graphite. Okay. Now we'll start with structure and the bonding of graphite. In graphite, each carbon atom is covalently bonded to 3 other atoms to produce an infinite 2-dimensional flat hexagonal layer structure, which is strong and hard. We are going to see the diagram as we proceed. The flat hexagonal layers in graphite are held together by van der Waals forces. We know that van der Waals forces is one of the weakest force of attraction. And this allows the movement of the plane parallel to each other and make the graphite to be soft and slippery. The 4th electron in the valency shell of each carbon atom in graphite is mobile because it is not used in bonding, and this accounts for electrical conductivity of graphite. You know, graphite is a good conductor of electricity because it has some free mobile electrons that are not used in the bonding. Okay. Look at the structure of graphite. By the left there is the structure
Please
of
go back.
diamond, and by the right is the structure of graphite.
Sir, please go back. Sir, please go back.
I should go back?
Yes, sir.
Okay. There are two things I want you to get from this particular slide. You need to know the structure of graphite. The structure of graphite is what?
Yes.
Hexagonal in shape. It's hexagonal in shape.
Yes.
Another thing you need to get there is that the force of attraction between the molecules is van der Waals forces, which is one of the weakest forces of attraction between molecules or atoms of carbon. Okay, and also the fourth electron in the valence shell of each carbon atom in graphite is mobile. What does that mean? They move about freely, and that's why graphite is considered to be an electrical conductor, because it has some free mobile electrons. And you know that it is the movement of electrons. The movement of electron is the same thing as the movement of current. So the movement of electron is a current flow in that particular element. So we look at the properties now of, no, we went back. I've been there. Okay. We look at the physical properties of graphite. Last week we talked about the properties of diamond. Can you mention any of those properties of diamond we mentioned last week? Sambo. Property of diamond. You have forgotten?
It is hard.
It is hard. It is the hardest substance known. It can cut any other substance, but no substance can cut diamond. That's good.
It does not conduct electricity.
It is not a conductor of electricity. It's a non-conductor because it doesn't have free electrons. Okay. Yes, another one. It has what? High density. It has what? High density, and so on and so forth. So now look at the physical properties of graphite. Like we said, graphite is soft, black, and opaque, and has hexagonal shape. You can see it in number 1 there. It's soft, black, opaque, and has what? Hexagonal shape. The softness is due to the ability of the adjacent layers to slide over one another. Number 2, graphite is hard. It has a density of 2.3 gram per cm cube, and melts at about 3,500 degrees Celsius. But it's not as hard as diamond. You know, the density of diamond is what? What is the density of diamond? I gave you last week.
3.5.
2.53 gram per cm cube. And this one is 2.3 gram per cm cube. So diamond is harder than graphite. In short, diamond is the hardest substance known. Number 3, graphite is a good conductor of heat and electricity. Now, this is a wire question here. Please mute your audio. This is a wire question. Sometimes you'll be asked, why is graphite a good conductor of electricity? Why is graphite a good conductor of electricity? The answer is what? It is because it has free mobile electrons. It has what? Free mobile electrons. So it is due to the presence of mobile electrons per carbon atom. That's why it's considered to be a good conductor of electricity. Another property of graphite is that graphite is soluble in any solvent. Can you mention any example of solvent you know? Yes, Uma. Solvent. Very simple now.
Yeah.
An example of solvent.
Salt.
What?
I said salt.
No, solvent. Solvent. Water is solvent. Kerosene is a organic solvent. Petrol is also organic solvent. So any solvent, graphite is soluble in it. So graphite is an example of non-metallic conductor. It is under the class of metalloid. So you cannot really call it a metallic conductor, but it is under the class of metalloid. Any question?
No, sir.
Okay, we'll move on. We look at the uses of graphite. Because graphite is soft, so it is used as a lubricant because of its soft nature. It's used as a lubricant. Number two, graphite is used as inert electrodes during electrolysis. Use them as electrodes because they are good conductors. Use them as electrodes during electrolysis and for brushes of electric motors, being a good conductor of electric current. Okay. Number three, when graphite is mixed with clay, graphite forms lead, which is used in making lead pencils. The pencil you use in writing, that dark thing in between the wooden cover is made of graphite. The hardness of a pencil depends on the amount of clay in the mixture. So they mix clay together with graphite to make that lead in the pencil. So you can see that some pencils, leads are hard, some are soft. So it depends on the amount of clay that is used to mix the graphite to produce the lead. Okay. Graphite is also used in making crucibles because of its high melting point. You know what is crucible? You want to heat something on fire, you put it on a crucible, either to dry a salt, you put it on a crucible to allow it to dry, either by heating it or allowing it to dry naturally under the sun. So you use crucible to do that. And this graphite is used in making crucible because of its high melting point. It has the ability to withstand some high level of temperature. Number five, graphite is used in nuclear reactors, being soft and with a high melting point. So we use them in nuclear reactors.
That's nuclear reactors.
Okay. Nuclear reactors are equipment that is used to make some nuclear bombs or missiles. Okay?
Close your mouth.
Please, when you are yawning, you cover your mouth. That is COVID-19. Okay?
Sir, can you repeat that explanation?
Any question? Samantha, are you following?
Yes, sir.
Okay.
I'm following. Yes, sir.
All right. So we'll move on to the difference or the differences between diamond and graphite. Can you see the table?
Yes, sir.
Okay. Number one there says diamond is transparent, solid, that sparkles when cut and polished. On the right, you see the graphite is opaque, solid with metallic luster. Number two, diamond has octahedral shape, while graphite has hexagonal shape. You can see it. The density of diamond is 3.53 gram per cm cube. It has a high density. You know what density is all about, the heaviness of the material. While graphite has a density of, that should be a mistake there, that's 2.3. Okay? Please, you can correct it, okay? That's 2.3 gram per cm cube. Then, diamond is a poor conductor of electricity, while graphite is a good conductor of electricity. Diamond is an inert substance, but at 900 degrees Celsius, bonds in air to form carbon 4 oxide, and also combines with fluorine. Graphite is more reactive, bonds also in air to produce carbon 4 oxide. You know, both of them are forms of what? Carbon. So when carbon bonds in excess oxygen, the product is what? Carbon 4 oxide.
Oh, please. Stop mentioning my parents. I just about had it.
Diamond is the hardest substance known. You already know that. While graphite is the softest material known. Any question on this?
Why?
Do you have any question?
No, sir.
No, so she's following.
Okay. Now we look at the properties of carbon. Now we are talking about carbon and its compound. So let's look at the physical and the chemical properties of carbon. We have seen the two physical forms of carbon, diamond and graphite. Let's see how they react chemically. Carbon bonds with limited supply of air to form carbon 2 oxide. You can see the question there. Carbon is a solid, reacts with oxygen in the air, this is the gas. Please mute your audio. Mute your audio. I will remove you from the class. You know that. So please look at the slide. You see carbon is a solid, react with oxygen in the air, which is a gas, to give you carbon 2 oxide in limited supply. If the oxygen is in limited supply, the product will be carbon 2 oxide. But if the oxygen is in excess, when you react carbon with excess oxygen, you're going to have carbon 4 oxide as the product. You can see it there. So don't mind the arrowhead there, it's shifting. Okay, you can see it. Carbon reacts with oxygen in limited supply to give you carbon 2 oxide. That CO is carbon 2 oxide. Then when the oxygen is in excess, the product will be carbon 4 oxide, that's CO2. Is that clear? That's one of the reactions of carbon. When carbon reacts with oxygen in limited supply, to give us carbon 2 oxide. When carbon reacts with oxygen in excess, the product is carbon 4 oxide. And this is known as combustion reaction. Combustion means what? Burning. Okay, we'll move on. Note, carbon occurs most abundantly both naturally as diamond and graphite in numerous compounds, including petroleum, coal, natural gas, and others. Now, second reaction of carbon is combination reaction. Carbon combines directly with certain elements, such as sulfur, hydrogen, calcium, and aluminum at a very high temperature. At a very high temperature. You can see the equation there. Carbon react with sulfur to give us carbon sulfide. Carbon also react with calcium to give us calcium carbide. You can see the equation there. In case you don't know the names of these compounds, as I mentioned it, you can write it under it in your book. Now, number 3, carbon is also a reducing agent. Carbon is a strong reducing agent. It reduces oxides of less active metals to their respective metals. For example, you can see iron 3 oxide reacts with carbon. So carbon reduces that iron 3 oxide to what? Iron. And then carbon 2 oxide is formed. So carbon is a very strong reducing agent. Number 4, reaction of carbon. Carbon reacts with strong oxidizing agents like triazonitrate 5 acid to form carbon 4 oxide. So carbon reacts with strong oxidizing agents like triazonitrate 5 acid to produce carbon 4 oxide. You can see the equation there. Triazonitrate 5 plus carbon give us carbon 4 oxide and nitrogen oxide, and water. Are you following? Any question? Do we need to go back to any? We have treated the structure of and bonding of graphite. Also looked at the uses of graphite, the properties, physical properties of graphite. We also looked at the reactions that carbon undergoes. Say carbon bonds in air to produce, that bonds in limited supply of air to produce carbon dioxide, and bonds with excess supply of air to produce carbon dioxide. We also have seen that carbon is a strong reducing agent. It reduces metallic oxides to their respective metals. We also see that carbon reacts with strong oxidizing agents, example triazole acid, to produce carbon dioxide. Okay, and we also have seen that carbon combines with other elements like calcium. Carbon reacts with calcium to produce calcium carbide. If there's no question, then I will ask you my own. If you don't have any question for me, I have for you. No question? Okay. Look at the evaluation questions here. Number one says, list 3 uses of graphite with reasons. Yes. Adekole, give me 1. Sambo, you give me 1. And Daniel Ayo, you give me 1. I'm waiting. Three uses of graphite with reasons. Yes. Is that Adekole? Yes. I'm waiting. Daniel Ayo.
Sir, when graphite reacts with clay, it's
No, I say
produces
uses. I continue.
It produces lead, which is used to make pencils.
Okay, it's used in making lead. This is used in making what? Pencils. That's good. Yes. Who answered that? Daniel? Then Adekole, please give me 1 use of graphite with resin.
Sir,
To answer.
sir, it's used in making cubicles.
Like chemicals like
Sir?
like
Sir,
what type of chemical is that? It's used for making lubricants. It's used for making lubricants. And why is it used for making lubricant? Because of its soft nature. It's the softest substance known. So because of its soft nature, it can be used for making lubricants. Yes, the next person.
Samantha.
Samantha.
Yes, sir.
Doesn't
Sambo.
it?
Or anybody that knows the answers, please, so you don't waste our time.
Diamond. Diamond is the hardest substance known, while graphite is
We
one
are
of
not
the
talking about the uses. We are saying number one. We are not saying giving me the differences. We are saying give me the uses.
Sir, it is used in making cubicle.
Making
Cubicle. Crucible.
Okay, it's used in making crucibles. That's good.
Because of
Now we go to number two. Give 4 differences between diamond and graphite. Yes, that one is easy. Now let's point them out. Diamond. Yes.
Diamond is octahedral in shape, while
Okay.
graphite is hexa something in shape.
Okay, hexagonal shape. Okay.
Hexa.
Another person should give us.
Hexa.
I still
Diamond
hear it.
is so why graphite is softest.
I can't hear you. Speak out.
Diamond is the best natural substance known, while graphite is the softest natural substance.
That's good. That's good. Yes, the next one.
Diamond is a non-conductor of electricity, while graphite is a conductor of electricity.
Okay, diamond is a poor conductor or a non-conductor of electricity, while graphite is a good conductor of electricity because of its free mobile electrons. Okay. Then we go to number 3 question. State 3 chemical properties of carbon. State 3.
Combustion reaction.
Okay, combustion reaction. Yes.
Combustion. Combination reaction.
Combination reaction. You don't, excuse me. When you are answering a question like this that has to do with chemical properties of any substance, chemical equation is required, very necessary. If you just make the statement without backing it up with a chemical equation, you have not done anything. So if it's a combustion reaction, you must back it up by saying carbon bonds in excess of air produce carbon dioxide, or bonds in limited supply of air to produce carbon dioxide. Then you write down the chemical equation. Without the chemical equation, you will not score 2 marks.
So what if you only read the chemical equation?
If you are asked to state the chemical or with the aid of chemical equation, state the chemical properties of carbon. If you write only the chemical equation, you will get your full mark, because they say with the aid of chemical equation. Okay, but if it is not stated like that, you have to explain and then write down the chemical equation under it. Is that clear?
Yes, sir.
Any question again?
No,
Before I
sir.
will give you the assignment for the day. Okay, you can see the assignment. We have almost answered part of the questions in the evaluation. You are to give 4 differences between diamond and graphite.
I know.
State the structure of diamond and graphite. Just state it. And with the aid of chemical equation, state 3 chemical properties of carbon. With the aid of chemical equation, state 3 chemical properties of carbon. Okay. All right. So with this,
Sir, please, can you briefly go through the notes?
the note from the beginning. Is it from the beginning? I can't hear you again. Who is asking question? Ask now, let me hear you.
Sir, please, can you briefly go through the notes?
The notes. from beginning to the end. Okay. Today we discussed about properties of graphite, differences between diamond and graphite, uses of graphite, and then chemical properties of carbon. Okay. What you need to know here, very important point you need to note down here is that graphite is the softest material known, okay? And it has hexagonal shape. The structure of graphite is hexagonal, okay? And then you need to understand also that the forces of attraction between the molecules of graphite is van der Waals forces, which is one of the weakest of attraction between molecules of any substance. Okay, that's what you need to know there. And also you need to know that graphite is a good conductor of electricity. This is because there are some carbon atoms, there are some electrons in the graphite structure that is not used in bonding. They move freely about. And as a result of those mobile free electrons, that's why graphite is a good conductor of electricity. You can see the structure of graphite by your right, okay? The one by the left is the structure of diamond. This is the octahedral shape of diamond. And this is the hexagonal shape of graphite. You can see it. Can you see it?
Yes, sir.
Okay. Now we have also talked about the physical property of graphite. Graphite is soft, black, opaque, and has hexagonal shape. Okay, it's also hard, but not as hard as diamond. Okay, it is a good conductor of heat and electricity because of the presence of mobile electrons. For it is soluble in any solvent. I mentioned so many solvents. Water is a solvent. Water is known as non-polar solvent. Then we have other organic solvents like petrol, kerosene, diesel, and so on and so forth. So graphite can dissolve in any of these solvents I've mentioned. So graphite is considered to be a non-metallic conductor. Okay, it is under the class of metalloid. Then we look at the uses. Graphite is used as a lubricant.